Hello and welcome back to Physics Aid. Before we get into talking about dynamics problems, I need to say something concerning the future content of this channel. Having taken the AP Physics 1 and 2 tests, I now understand how much practice and becoming familiar with the types of problems is important when studying for the exams. So instead of the usual overview of the material, I have decided to shift the focus of these videos to explaining certain problems that to me were particularly challenging when preparing for the test, or just problems that tend to show up a lot. Therefore, any viewer who is here to learn the material for the first time, I recommend you instead go to either Khan Academy or Bozeman Science. The problems I will be using is from Mcgraw Hill Education's book on the AP Physics tests, 5 Steps to a 5. I will note on the side which problems I'm using too, so anyone who's using the book for preparation can come to these videos to get a visual representation of how the problem is solved, instead of just reading it. I know from experience that it's hard to absorb information through reading when you're in the library at 2 a.m. and the exam is next week. And without further ado, let's get started. The first problem we will be covering is one surrounding the concept of Newton's third law, which I am fairly certain all of you have heard of and directly experienced. To me, one particularly annoying instance of hearing its use is whenever my friend pokes me, he says, "Newton's third law states that your shoulder's actually poking my finger," or something stupid like that. I'm just going to put up the definition of Newton's third law in the corner for reference if you need it, although hopefully you've already memorized it by now if you're preparing for the exam, otherwise it'd be very concerned for you. With the following diagram, a person pulls on a string, causing a block to move to the left at a constant speed. The free body diagram shows the four forces acting on the block: the tension T in the string, the normal force Fn, the weight W, and the friction force Ff. The coefficient of friction between the block and the table is 0.30. This is a two-part problem, and the first part asks, which is the Newton's third law force pair to T? It asks for the Newton's third law pair, which would be the reaction force to the tension in the string. At first glance, the obvious choice would be Ff, the force of friction. However, when you really consider what Newton's third law states, the real answer is A, the force of the block on the string. Why isn't it D? Because the law states that since the string exerts a force on a block, the block exerts a force back onto the string. This is a separate phenomenon from the force of friction. Friction is simply the counteracting force due to a rough surface, which is unrelated to the string's force on the block. With problems like these, a good lesson to learn is that you should be very careful when thinking about the forces involved. It's also very important to have a firm grasp on what the laws of motion dictate. Moving on, we will have another problem involving force diagrams. An object hangs by a string from a car's rear view mirror, as shown in the picture. The car is speeding up and moving to the right. Which of the following diagrams correctly represents the forces acting upon the object? The following options are given. You can see that the distinguishing features of each option is the varying location/display of the force of the object on the string. In reality, such a force would be pointing in the opposite direction of the tension force, making A appear to be a likely solution. However, in a force diagram, the only forces that are shown are forces that are exerted on the object, not forces that the object exerts on other entities. It seems really dumb, but the real answer is D, because the force of the object on the string is exerted by the object, therefore should not be represented in the force diagram. This is a pretty simple problem if you know the details on how force diagrams are used, so make sure you are familiar with these concepts. Last problem, and guess what? It's another force diagram problem. Yeah, there are way too many of these on the test. If you don't get used to analyzing them and making your own, it will become significantly more difficult to score high. Now, which of the following force diagrams could represent the forces acting on a block that slides to the right while slowing down? Now, unlike the other properties, this one is a little less nitpicky when it comes to details. The first thing to notice is that the object is slowing down. It's decelerating. Therefore, according to Newton's first law, if the object is decelerating, then that means there must be a net force, especially when that counteracts the motion. Objects B, C, and D are out of the question because C states that there is no horizontal net force, and B and D include a force of motion, which is absurd and certainly does not exist. Then by due process of elimination, the answer is A, because the friction slows down the block and is moving right. Having explained it, it seems very simple, but there are indeed moments in the AP test when you're running out of time and you just don't have time to think clearly. That's why an important part of the test is making sure you maintain a calm mindset, otherwise you get a lot of problems wrong that were actually really easy by sheer mistake. That pretty much wraps everything up for today. At the end of each video, I'll just give a quick few tips on how to approach the kinds of problems we talked about. For problems surrounding just forces, there's not much else to say other than just to watch out for little details. Also, I cannot stress this enough, but the most important part of the test is understanding the material inside out. Yes, you are given a calculator, and yes, you are given an equation sheet, but by no means does that mean an easy 5 on the test. As you can see, none of the problems that I presented today even required calculations, neither did they require knowledge of the equations given. The AP exam tests you on utmost conceptual understanding, rather than algebraic skills or being able to plug stuff into equations. Always keep that in mind. Anyway, goodbye and see you all in the next video.